Hello and welcome to the Solving Rational Functions Day 2 video. In this video, we're going to be continuing with the same linked notes as yesterday, but now we're just going into some more of the more challenging problems as well as extraneous solutions. So we're going to be doing two problems together. We're going to do problem number 7 and problem number 12, and making sure that we're checking our answers along the way. So let's get started. Problem number 7 is 4 over b minus 4 minus 3 over b minus 3 is equal to 1. So the first thing that I see here are two fractions that we're trying to subtract. If you're trying to add or subtract fractions, make sure you find a common denominator. So in this case, I'm going to multiply the denominators by each other. So my left fraction, I'm going to multiply by b minus 3, and my right fraction, I'm going to multiply by b minus 4. But here's the thing. You cannot just multiply to the denominator. Whatever you do to the denominator, or the bottom of your fraction, you have to do the same thing to the numerator, or the top of your fraction. So again, for my left side, I'm going to multiply by, b minus 3, and on my right side, I'm going to multiply by b minus 4. So my new fraction is going to look like 4 times b minus 3 over b minus 3 times b minus 4, minus 3 times b minus 4 over b minus 3 times b minus 4, and all of that is equal to 1. Now, since these have the same denominator, and we're trying to get rid of a fraction, well, how do you undo a fraction or division? With multiplication. So I'm going to take this whole equation, and I'm going to multiply the whole thing by b minus 3 times b minus 4. So if I do that, if I'm multiplying and dividing over here, this goes away. If I'm multiplying here and dividing here, this goes away. And then I have this 1 times this stuff. So this doesn't cancel out on my right side. So this is going to end up being 4 times b minus 3 minus 3 times b minus 4 is equal to that right side. So 1 times b minus 3 times b minus 4. And since 1 times anything is that anything, we just end up with b minus 3 times b minus 4. So from here, we're already done with our fractions, only a few steps in. Now we're going to take some time and distribute and factor. So I'm going to take this 4 and multiply it inside here. Take this negative 3, so I'm taking the negative with it, and multiplying it inside here. And then I'll also be foiling on the right side, but I'll do that in just a moment. But on my left side, we're going to have 4b minus 12 minus 3b plus 12. So that's what we're going to have on our left side. On our right side, when we FOIL, first is b times b, or b squared. Outer is b times negative 4, or negative 4b. Inner is negative 3 times b, or negative 3b. And outer is negative 3 times negative 4, or a positive 12. So when I simplify both sides, on my left side we have a minus 12 and a plus 12, so those will cancel each other out. And then 4b minus 3b just leaves us with b. And on our right side, when we combine our like terms, we're going to end up with b squared minus 7b plus 12. So now when I take a look at this, I go, you know what, I have a squared, something with a variable, and a constant. I'm probably going to have to factor or use my quadratic formula. And in order to do either of those, I need to move everything over to one side of the equal sign and set it equal to 0. So I'm going to subtract that b on both sides and get 0 is equal to b squared minus 8b plus 12. Now I'm going to look for two numbers that multiply to 12 and add to negative 8. When I do that, I get 0 is equal to b minus 2 and b minus 6, since negative 2 plus negative 6 is negative 8, and negative 2 times negative 6 is positive 12. So now to solve for these b values, I'm going to set each of these factors by themselves equal to 0. And when I solve to get b by itself, we get b is equal to 2 and b is equal to 6. So in this case, we have two answers. That's okay. Let's just go through and check our work to make sure that both these problems work out. So in our check, I'm going to do that over here. In our check, first we'll plug 2 into the equation. So we'll have 4 over 2 minus 4 minus 3 over 2 minus 3 is equal to 1. Let's see, that left side is going to become 4 over negative 2 minus 3 over negative 1 is equal to 1. 4 over negative 2 gives us just a negative 2. And a negative 3 over negative 1 gives us a positive 3. And negative 2 plus negative 2 plus 3 is 1. All right, so we got 1 is equal to 1. We know that 2 is in fact one of our answers. Let's check with 6. So if we check with 6, it's going to be 4 over 6 minus 4 minus 3 over 6 minus 3 is equal to 1. So let's see, now we end up with 4 over 2 minus 3 over 3 is equal to 1. 4 over 2 is 2. Negative 3 over 3 is minus 1 is equal to 1. Negative 2 minus 1, or probably positive 2 minus 1 is equal to 1. All right, they've both checked off. They're both correct. So now that they're both available as answers, I'm going to put my final answers in a solution set. So it's going to be in curly brackets, and we'll list them from least to greatest, saying, hey, all of these answers work. So this is what one full problem looks like, with maybe some more complicated math than yesterday. And I think this is looking pretty good. But so far we haven't come across anything that doesn't work when we check it. So let's talk about an extraneous solution. An extraneous solution is something that you can solve for, but doesn't actually work in the problem. And I'll let you know right now, number 12 is going to have an extraneous solution. So let's see what that looks like. Problem 12 starts with 5 over x squared minus 7x plus 12 is equal to 2 over x minus 3 plus 5 over x minus 4. Okay, so just like we did in the other problem, I noticed two fractions that want to be added together. In order to add fractions, you need to have a common denominator. So I'm going to multiply the denominators by each other. So the fraction on my most right, I'm going to multiply by x minus 3 top and bottom. And fraction on my the other side, I'm going to multiply by x minus 4 top and bottom. And then I'm also going to take a look here at that right side, or pardon me, my most left side. I'm looking for two numbers that multiply to 12 and add to negative 7, so I can factor this out. Well, when I factor this out, two numbers that multiply to 12 and add to negative 7 are negative 3 and negative 4. So this becomes x minus 3 times x minus 4 is equal to my fractions that we've now multiplied. So this will be 2 over x minus 4 times x minus 3 times x minus 4 plus 5 over x minus 3 times x minus 3 times x minus 4. So from here, I take a look and I go, hey, all of our denominators are the same. So how do I get rid of these fractions? How do I undo division? Well, with multiplication. So I'm going to take this whole entire problem and I'm going to multiply by x minus 3 times x minus 4. And I can do that because I'm multiplying the whole thing, not just one piece. But from here, I can see if I'm multiplying here and dividing here, this will cancel. If I'm multiplying here and dividing here, this will cancel. And again, if I'm multiplying here and dividing here, this will cancel. So we've already gotten rid of all of our fractions. And And we're just going to be left with 5 is equal to 2 times x minus 4 plus 5 times x minus 3. So next I want to distribute the 2 inside this parentheses and the 5 inside this one. So we end up with 5 is equal to 2x minus 8 plus 5x minus 15. Then we want to combine our like terms. So we have a 2x and a 5x over here. That's going to give us 7x. So we'll have 5 is equal to 7x. And then we have a negative 8 and a negative 15. That's going to combine to be a negative 23. So now in order to get x by itself, I'm going to add 23 to both sides and get 28 is equal to 7x. And then to get x by itself, I'm going to divide both sides by 7. And I get x is equal to 4. So we have an answer for x that we were able to solve for, but let's go through and look at our check. So if I was to take this 4 and plug it back into the equation, I want to know what happens. If we do our check over here, we're going to have 5 over 4 squared minus 7 times 4, whoops, where are we at? There we are. Plus 12 is equal to 2 over, that's a 4 minus 3 plus 5 over 4 minus 4. So if I take my next step and I try to simplify, I'm going to have 5 over 16 minus 28 plus 12 is equal to 2 over 1 plus 5 over 0. Now I take a look right here and I'm like, ooh, we're not supposed to divide by 0. That's something really bad. We've talked about this a lot. So for right here, cannot divide by 0. So we know that, hey, like, yeah, we were able to go through and solve for 4, but if we were to plug in 4 and use it as our actual x value, we come up with something that's undefined, that's not supposed to happen. Well, this isn't a case of an extraneous solution. So an extraneous solution is an answer you can solve for, like 4, but doesn't actually work when you plug it back in. This is why we always go through and check our answers just to make sure everything works out. But anyway, now we can see that, hey, x is equal to 4, not going to work for us. So I'll go, are there any other solutions, like maybe in our last problem when we have 2? In this case, there isn't any other solutions. So this ends up being a no solution problem. And that's okay. You'll run across these at some point. So please make sure to always go through and check your work just in case there are any extraneous solutions. There's going to be a few in the Go Formative that you're going to work on tomorrow, so I'll make sure to go through those again just to remind you. But this is the last of the new material for the term. So give yourself a pat on the back. Let me know if you have any questions. I look forward to seeing you tomorrow.